Right, so 2.3 is parent functions. And you're going to need graph paper. If you're watching this to get your notes for the first time, then you need some graph paper. Follow the instructions on the screen so that you can graph 8 different functions. So as we're graphing these, you need to make sure that you're paying attention to some specific points because when you graph them on a test, they're going to be looking for specific points that have been transformed when we do transformations, which is the back half of this lesson. All right, so a constant function is just y is equal to some number. We like to use 2. So if y is equal to 2, you get a horizontal line that crosses 2 on the x-axis. Hopefully they don't actually make you try to like do any kind of transformation to that, but I just wanted to include that that's what a constant function is. The identity function is the basic linear function. So just y is equal to x. And so then we know that goes through 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. Keeps going as long as y and x are the same. Then you have, and it goes through the origin. I really thought I'd turn that blue. Oh well. All right, so that's the identity function, or the parent for the linear. All right, absolute value. For absolute value, it's going to be y is equal to absolute value of x. So the points we need to know for this are the absolute value of 0 is 0, absolute value of 1 is 1, absolute value of negative 1 is 1. Those are the 3 points you're going to need to know. We also have that the absolute value of 2 is 2, negative 2 is negative, the absolute value of negative 2 is also 2. So for absolute value, you get this V-shaped graph. That's like y equals x, but instead of having the negatives, we flip the negative ones up and make them positive. All right, so that's the parent graph for y is equal to absolute value of x. All right, for a quadratic, that is y is equal to x squared. That's the parent. So if we do 0 squared, we get 0. If we do 1 squared, we get 1. If we do negative 1 squared, we get 1. Really, that's the only 3 you need for a transformation, but you need to know what it looks like. So if we think about 2 squared, that's going to jump us up to 4. Negative 2 squared jumps us up to 4. And in between here, like if we do a half squared, it's only going to give us a fourth. So a quadratic is going to make a U-shaped graph. I'm going to give this one more shot, and we're going to pretend like it's pretty, whether it is or not. It can't be that bad off. All right, there we go. All right, for a square root function, the parent is y is equal to the square root of x. We can't plug in negative numbers because the square root of a negative is imaginary. The square root of 0 is 0. The square root of 1 is 1. The next pretty point would be that the square root of 4 is 2. And then we'd have to go all the way to the square root of 9 is 3. So these 3 points are good enough. You just need to know that this is going to start leveling off. All right, so again, you need 3 basic points and the idea of what the shape is. That's what you need to have like memorized so that on a test you can give me what we need. All right, so for a cubic function, y is equal to x to the third. So we talked about this in the previous lesson, that if you take, say, negative 1 and cube it, you get negative 1. If you take 0 and cube it, you get 0. Take 1 and cube, you get 1. It looks like we're making a line. So we have to know what happens next. If you take 2 and cube it, you get 8, which puts us like way up here. Negative 2 to the third is going to be negative 8. So way down here. So this is going to curve and shoot up really high, and this is going to curve and shoot down really low. So that's what a cubic graph looks like. So these 3 points are all you need as long as you remember what it has to make as it goes through those 3 points. All right, for a cube root function, you're going to take what we just did and turn it sideways. The cube root of -1 is -1. Cube root of 0 is 0. The cube root of 1 is 1. We have to go all the way out to 8 before we get another perfect cube. The cube root of 8 is 2, and the cube root of -8 is -2. So this is like, it looks a lot like the square root function, but it has a tail. It goes both ways, where the square root function only goes one way because you can't do negatives with an even root. Okay, pretend like that's going through that point. All right, rational function, also known as the reciprocal function, because the parent is y equals 1 over x. So if we think about what that means, I'm going to make a big table over here. If we have 1, then we get 1 over 1, so we're still 1. If we have -1, which is what that one should have been, we get 1 over -1, so -1. We try to do 0, we get 1 over 0, which is undefined. If we do 2 or -2, we're going to get 1 over -2, so -1/2. Or we're going to get 1 over 2, so a half. And then we need to know what's happening at the half. Also, what happens when I give you a fraction. It's going to be 1 over that fraction, or the reciprocal of that fraction. So we would get -2 here, and we would get +2 here, because I meant for that to be a +1/2. All right, so that's a little cramped, but we get the idea. -2, if I flip that, if I do the reciprocal of that, I get -1/2. At -1, I get -1. At -1/2, the reciprocal of that is -2. At 0, I'm undefined, so I have an asymptote of that y-axis. At 1/2, the reciprocal is 2. 1, the reciprocal is 1. At 2, the reciprocal is a half. So what's going to happen is you're also going to have an asymptote of the x-axis. Your rational function will look like this. This is not going to be asked of you on a test, but it probably will show up in Math Excel. All right, so that is your parent functions. I don't know why that says 2.5. That should say 2.3. Um, all right, so that's your parent functions that you need to know. We'll talk about other functions in chapter 4, but for now, those are the ones we need. The rules for transformations, you've learned them before, but here's a nice little succinct package. If I take a function and I add something to the back, we're going to move up. So we're going to change the y. If I subtract on the back, we're going to go down. So again, change the y. Anything on the outside of the function is going to change the y's. Anything on the inside of the function will change the x's. So like this, if I do a plus on the inside of some kind of grouping symbol, it's going to go left. A minus on the inside is going to go right. All right, so if you'll remember that outside does what it says. So we're going to say same to y's. And then inside, we'll do the opposite of what it says to the x's. That's what it boils down to. If I'm changing something about the outside of the function, outside of some kind of grouping symbol, outside of parentheses, outside of absolute value, then it's going to affect the y's and do exactly what it says. If it's on the inside, though, like inside absolute value, inside parentheses, inside the square root, then it's going to do the opposite of what it says to the x's. All right, so negative will flip. If it's on the outside, it changes the y, so it flips over the x-axis. If it's on the inside, it changes the x, so it flips over the y-axis. Multiplication will stretch or compress, like stretch or shrink. If it's on the outside, big numbers stretch, fractions smaller than 1 compress. But if it's on the inside, again, it does the opposite. So big numbers are going to compress and numbers between 0 and 1 are going to stretch. All right, so the way this looks, what's going to be expected of you in Math Excel and on a test, you need to know what the parent looks like. So we need to know that the parent graph is the absolute value of x, and we need to know that it looks like this, with the points -1, 1, 0, 0, 1, 1. All right, then we need to know that this tells us to go up 3, which means we're going to take our y values and add 3. So our g of x function is going to have ordered pairs at -1, 4, 0, 3, and 1, 4. I just added 3 to the y values. So -1, 4, 0, 3, 1, 4. And then you just make the same absolute value graph. All right, so again, on a test, they want to see this. They want to know what points you're using and how you're transforming them. In Math Excel, at most of the time, they want you to graph both. So you'll graph the parent and the new function on the same graph. All right, and then they want the domain and range. So domain is all real numbers. And the range for this one, we start at 3 and we go bigger from there. All right, number 2. Again, identify the parent. This is a cube root, so we're working off of this guy. We know that it should look something like this. We have points at -1, -1, 0, 0, and 1, 1. Then the change we're making, we have -5 on the inside, so that's going to take us to the right 5, which is going to add 5 to those x values. So we're going to have 4, -1. This one is going to become 5, 0. This one's going to become 6, 1. So 4, -1, 5, 0, 6, 1. And remember, we're making this shape, so it's going to look something like this. All right. Number 3. This one is a quadratic. So we're going to have a U-shaped graph. Our parent is this. We know that it will look something like this when we graph it. We know it'll go through -1, 1, 0, 0, and 1, 1. So then we have 2 things happening. So first of all, this +2 is going to change the y values, move us up 2. And so we're going to add 2 to the y's. This negative out front is going to change the y values also. It's going to reflect, because it's not in parentheses, it's going to reflect over the x-axis. It's going to change the y. So I need to do 2 things to the y. So actually I wrote this prematurely because we have to follow the order of operations. So we're going to multiply by -1 and then we're going to add 2. All right, so our new ordered pairs, the x's are not changing. We haven't done anything that affects the x. What we're going to do is take this and multiply by -1. So we'll get -1, add 2, and we get back to +1. Multiply by -1, you get 0. Add 2, and you get 2. Multiply by -1, you get -1. Add 2, and you get 1. So -1, 1, 0, 2, and 1, 1. So what we've done is flipped our u upside down and slid it up 2 units. So we should get something that looks like that. All right, number 4, our parent is the square root function. So we should get something that resembles this. We go through 0, 0, 1, 1, and 4, 2. And then again, we got 2 things happening. One on the outside, one on the inside. So the one on the outside is going to change our y's. It's going to be a vertical stretch by 3. So we'll multiply by 3 on the y's. The one on the inside is going to change the sign of our x's. So we'll multiply by -1, but that's actually going to reflect us over the y-axis because our x's are going to change from positives to negatives. All right, so we'll get, this will still be 0, 0. This one will become -1, 3. This one will become -4, 6. So 0, 0, -1, 3, and -4, 6. All right, so we're trying to make this shape, but we're reflecting it the other way and stretching it out, making it taller. So we're going to start here and it's going to go taller. This is a struggle. I'm going to draw backwards of what I'm saying, but we're going to start here and stretch it out and go taller. It should look something like that. All right, so number 5, this one is a quadratic again. So our parent is x squared. So our little U-shaped graph. We have -1, 1, 0, 0, 1, 1. All right, I'm going to color code this one because there's a lot going on. So first of all, this negative is going to reflect over the x-axis because it's on the outside. It's going to change the sign of the y's. So we would multiply those by -2. All right, then we have the 2. So that's going to be a vertical because it's changing the y's stretch because it's on the outside. It does what it says. And I said -2 here, and I meant to say -1, but when you put those together, multiply by -1, multiply by 2, then you do get that we're multiplying by -2. Apparently I was thinking ahead of myself. So multiply by a negative for the reflection, multiply by a 2 for the stretch. All right, so then we have the +3 on the inside, so that's going to take us to the left 3. So we're going to subtract 3 from those x's. And then the -1 on the end is going to take us down 1. So once we multiply by -2, then we will subtract 1 from our y's. All right, so our new points, -1 minus 3, so -4. Multiply by -2, so -2, and then subtract 1, so -3. Multiply by -3, so 0. Multiply by -2, 0. Subtract 1, -1. Multiply 1 by -3. Oh, that's not multiplying, that's subtracting. Sorry. Sometimes I confuse myself. I apologize. So this would be a -3 because we're subtracting 3 from 0. So 1 minus 3 would give me -2 for this last point. And then 1 times -2 is -2 minus 1 is -3. All right, so -4, -3, -3, -1, -2, -3. And then you have a parabola. And we know it's going to face down because it started out negative, which reflected it. All right, I believe that's the last one. Yes. All right, let me know if you have questions.